In the face of tremendous technological development at unprecedented and exponentially increasing speeds, we stand at a pivotal moment to decide whether or not we actively accelerate humanity's natural evolution. And if we do, then how? Welcome to Superhuman.
All right.
Good to see you, Emil.
Same.
Okay, so my dad is in his 70s.
Right.
He's beginning to experience cognitive decline. Cryopreservation is an option for him. How do I talk to my dad about this? What is it? What does he need to think about?
Yeah. So it is a technology where, should you die, instead of choosing the cremation and burial path, which is unfortunately what most people currently choose, right, or need to choose, you instead do what you know from science fiction movies, where you cool down the body in a capsule, right? You keep it at negative 320 Fahrenheit, negative 196 Celsius, so extremely low temperatures, right? But you don't freeze, you cryopreserve. And of course, I'm going to introduce what that is in detail. And then the hope, the idea, the prediction is that at some point in the future, you might be able to cure the underlying condition, right? Neurodegeneration, cancer, whatever it is, and then bring the person back once we can figure out all the rest. And then that person might be able to, live happily ever after.
Okay, so let's do a role play here. You're me.
Right.
I'm my dad.
Yeah, okay.
Okay,
yeah.
give me a call and tell me what's going on.
Right. Hey, Brian, I don't know what your dad's name is.
Richard.
Richard, hey. So listen, honestly, if you have neurodegeneration, I would wait as long as possible. Cryopreservation, there's still a lot of open questions, right? But to be fair, depending on what type of neurodegeneration is, and we try to not give any advice, honestly, it's a very, very personal decision. Do you want to do this in quotation marks early? Or do you want to wait until the doctors tell you the person is going to die soon and do it as a last-ditch effort?
So you're telling me I don't have to do it now. I can wait. I experience decline, and even if I don't know what's going on, if I've signed the paperwork before I become mentally unwell, I can still do that. But does that affect how I'm then taken out of cryopreservation? If the technology works, do I still have cognitive impairment?
Very good question. It really depends on what kind of neurodegeneration you might have, right? So there might be neurodegeneration where what is currently not curable might be curable in the future. But there is also certain types of neurodegeneration that might not be curable, where you cannot just bring the memories back, right? They're just gone.
So I may want to do this now.
Yeah, so we would not advise any direction, either direction here. You can legally do that in some countries of the world, right? But it's a very, very personal decision where we, to be fair, don't want to be involved in that decision.
But I understand there's a trade-off, that if I wait, it potentially is a higher risk for me.
Tentatively, yeah.
Yeah, how many of you have parents that are in this situation? Yeah, this is real, right?
Yeah.
How many of you would talk to your parents about this? Like raise you, yeah, cool. It's amazing. All right, cool. So you're going to get into the technology.
Yes.
It's really cool that we actually exist in a time and place where this is actually a possibility for someone to do. And like, how insane is it? So, cool.
Let's do it. Thank you, Ryan. All right. So in most cases, right, this technology is being used when people die due to cancer or to some disease that is not neurodegeneration. And when my slides arrive, then I'm also happy to walk you through. All right, starting from the top. So it's a moonshot, right? Cryopreservation is not, I still have my fingers crossed that one of the other technologies will figure it out. But I've been working on longevity now for many, many years. That's why I studied medicine, 20 years ago. The problem is that the field doesn't progress fast enough. And let me tell you why we work on this. There's a tremendous amount of people, if you ask them, how long would you like to live, that say, I would like to live indefinitely, right? So significantly longer than currently possible. I don't know if I want to live forever, but at least I would like to live another day tomorrow, right? And I don't think when I'm 85 that I'm going to change my mind. At the same time, currently, with all the longevity research that has been done over the last, decades by now, there's currently 0 drugs, 0 treatments, 0 interventions that let you live longer. They get you to be healthy when you're old, but nothing extends a maximum lifespan right now. So these curves kind of show that, right? These curves basically show on the y-axis how many people are alive, and on the x-axis how old people are, right? And then over the years, 1900s, a lot of people were already dead when they're 50. Right now, almost everybody makes it to 50. But the point is, all of these curves end somewhere between 80 and 90. So even though we're able to make more people reach the age of 50, 60, 70, everybody is still dead at 80 or 90. And when I came back from a hiking trip, after I have done all the other longevity interventions at 85 with my friends, right, and then the doctors tell me, I have 6 months to live, I'd rather go on the next hiking trip when I'm 100, right? So more and more people, when they get older, they're healthy, they're in relatively good health. And even if you ask people right now who might not have good quality of life, do they want to die? 70% of the population says, I would like to live longer, even though I might not have the greatest quality of life. And why am I pessimistic? I'm coming from the field of cancer research. This was kind of what I did during med school. The cancer field is the perfect example of a field that every 10 years says it's just another 10 years. And currently, the longevity field kind of does that as well a bit. We're just on the cusp of figuring out how to live longer. There was, just as an example, there was the so-called Directors Challenge. This was in 2005, when the National Cancer Institute said, we want to cure cancer by 2015. Of course, 2015 is now 10 years ago. Cancer is still the second leading cause of death. And since then, we've spent $500 billion on research. Biology is just really, really, really hard. This picture is just a small chunk of what's going on in ourselves, right? So figuring this out, how to let people, not adhere to this, but just live longer and not die due to all the metabolic processes and aging and so on, is just really, really, really hard. And I was optimistic in the past, and then after being in academia for a while and doing research, the more and more I knew the field, the less and less I got optimistic. Don't get me wrong, there is progress, right? There's stuff in the past that we could not have imagined just, 50 years prior. This is a picture from the first heart transplantation, where we take one heart from one human and put it into another human. Right? Currently, of course, this is totally standard procedure and it's being done in hospitals around the world every day. But 10 years, 20 years before that was done the first time, it would have sounded like science fiction. Right? One heart and bring it to human, the human survives. So the point here being is that while it's very difficult to predict how fast stuff will go, fundamentally, stuff that is almost unimaginable might be very well standard practice in the future. And now, let's come to what we do. We do this, but in reality. The stuff that you know from science fiction movies, where, just as I said, instead of, having the person, when they go with a starship to another planet that is 40 light years away, instead of having the actors age, right, you put them into Cryosleep, you wait it out, and they wake up without having aged a day. And of course, we do that in reality. It doesn't look as nice as, movie-like as it is in this picture, but it's just the same fundamental idea. Now, this looks how it looks in a kidney, right? On your right side, you have a vitrified kidney. This is what we do. This is what cryopreservation is. On the left side, you have a frozen kidney. The frozen kidney is basically works as much as when you put a tomato into your freezer and you take it out. It's not a nice tomato after. Right, the freezing destroys the structure, it doesn't work, it's just a clump of tissue, it's just a clump of mush. But the right kidney that has been cryopreserved, if you warm this up and transplant it back into an animal, the animal survives, the kidney works. It works because it was cryopreserved. And it doesn't matter if you keep it in cryopreservation for a day, a week, a year, 10 years, 100 years, however long you might need to. And of course, in humans, you would do this because currently, people die due to diseases that are just not curable right now. The people who are in cryopreservation with us, They're usually relatively young people even, who just had the unlucky circumstance of being diagnosed with pancreatic cancer that is metastasized, ALS, something that we currently cannot cure. But then again, in the past, right, there was a lot of diseases that were not curable. Infectious diseases killed a tremendous amount of people in the past. Now you take antibiotics and you're fine, at least in most cases. Now, it's very much believable, and I think I would even say that's probably how it's going to go, that something that is not curable today will be curable in the future. The problem is, if you have a terminal condition right now, you're just not going to be around in that future. And now, as hard as this sounds, people who have terminal conditions or get diagnosed with terminal conditions right now, they have two choices. They can either say, I want to be cremated or buried, and at least on my worldview, that's it. There's no coming back from cremation or burial. Or they can say, I'd rather be cryopreserved. Basically, like the kidney here on the right. With the chance, and it's very important for me to say, this is just a chance. People have been put into cryopreservation, but no one has been taken out yet. Right? Because this is not a story. This is tangible reality. This is my research institute in Switzerland, where we have long-term cryo storage with people who have died due to these terminal conditions in those tanks. And now there's a lot of asset management behind it to be sure that you can maintain that cryopreservation pretty much indefinitely. Right? Because I don't know if it's going to take 20 years or 30 years or 50 years or 100 years. But again, remember the alternative would be cremation. That's the research institute. It has an operation room, imaging to make sure that we can have quality assurance for these people who are in cryopreservation, medical teams who do these procedures, doctors, perfusionists, and so on and so on. And we have medical teams that if one of our people who are signed up with us, who have decided to rather be cryopreserved than cremated, wherever they are, we would send one of these teams to them. And then the second the doctors say, we've tried everything. We've tried, all intervention, but the person is going to die. The second the person is pronounced legally dead, then our team immediately takes over, cools down the body, does chest compressions and so on, does everything to keep the cells in the brain, most importantly, from degrading. Of course, this needs to be done very, very quickly, right? And then at some point, you replace all the blood and all the water in the body against pretty much a medical-grade antifreeze. It's a solution that lets you cool down to then look like the cryopreserved kidney and not the frozen kidney, to be able to potentially be brought back in the future. These teams are all over the world, right? In the US, in Europe, we're building now a couple more teams. Even if you die on an island somewhere, right, which statistically is not going to be super likely, we still fly. We have flight teams that then would fly to you and pick you up from wherever you are as quick as possible. Now, but does this actually work? Right? We already talked about the kidney. The kidney is a very good example that, where you show that fundamentally the technology of cryopreservation is sound. It's in fact the same technology that you use for in vitro fertilization, where you cryopreserve egg cells and then you're able to use them down the line. There's small animals, small model organisms in the lab that can be fully cryopreserved, can be taken out, they keep their memories. I mean, it's not like human memory, it's C. elegans, it's a small worm, so I wouldn't say it's directly the same, but at least it is, neurally encoded memory. They replicate, they continue living on. In humans, we at least can show that the brain in cryopreservation, there's no ice, everything that's green here, there's no ice crystals in that region, right? So you can show that at least we can people put into cryostasis. We can't take them out yet, but the trick, of course, here being that for the taking out part, if it takes 50 years, it takes 50 years. If it takes 100 years, so be it. If it takes longer, that's also fine. Time doesn't matter anymore once you're in cryostasis. The fundamental logic here is that the parts that make you, the parts that make me, those parts are cryopreserved. And as much as neuroscience right now knows, this is basically three big things. It's the connections in your brain, It's the weight of those connections, right? How strong is a connection? And then it's kind of the internal computation of one cell. Of course, this is a super simplified picture, but we recently ran a study from neuroscientists and asked them, like, the things that we care about, memory, identity, personality, consciousness, how is that encoded in the brain? And the largest chunk of neuroscientists said, yeah, the parts that are preserved in cryopreservation, the synapses, the connections, and so on, those make you, those make me. And I don't want to say that I have all the answers and every question for cryopreservation is answered. I think the very important consideration here is cryopreservation is not something that I want to do. In fact, I don't want to be cryopreserved. I'd much rather take the treatment, the pill, whatever it is in the future to allows me to live happily ever after, right? But again, everybody in the past who thought that we're just gonna be, then the pill is gonna be around soon. You know, if you went to longevity conferences over the last, decades or so, initially it was calorie restriction, just eat less and you're gonna live much, much longer. Then it was just make your telomeres longer and you're gonna live longer. Like there's always like the new hype that now is the cool thing that you need to do. So far, again, nothing works. And unfortunately, all of us might be that question might be something that some people need to answer. Do you want to be, if push comes to shove, do you want to be cremated or do you want to be cryopreserved? My personal answer is very clear. If that's the question, I choose cryopreservation every day of the week. Not because all questions are answered, just because the other option is, in my mind, significantly worse. Cremation, the chance is 0. Cryopreservation, at the very least, it's better than 0. Thank you so much.